So this is the Leaving Cert Ordinary Level 2023, Paper 2, Question 2. So it says S is a circle, x squared plus y squared is equal to 25. Write down the centre and the radius of this circle. Okay, so we need to be able to use the log tables for this. So we go to the log tables, we open up page 19. That's everything to do with the circle. And what we need to do is we need to look for the equation of a circle. And there's just a couple of things we need to know. So here's the general equation for a circle. So that's this here. For the equation of a circle with a centre h, hk and a radius r. So I've just brought that in there, and we can see there that we have x squared by itself, so there's no h, and we have y squared by itself, and there's no k. So that means that the centre is going to have to be 0, 0. Okay, so anytime you're given a circle that has an x squared plus a y squared equals a number, it has a centre of 0, 0, and from that we can see that the radius there is going to be the square root of 25. So the square root of 25 gives us 5. So that's the first part of that question done. For part 2, show that the point 3, negative 4 is on the circle S. Okay, so if we're proving that a point is on a circle, we have an x value and a y value, and we can sub them in. So instead of x, I'm going to say 3. So take my equation, x squared plus y squared equals 25. And instead of x, I'm going to put in 3. So 3 squared will be my first value, plus, and instead of y squared, I'm going to put in the y value. The y value is negative 4. So I'm putting in negative 4 to be squared, and I'm going to leave that equal to 25. Okay. The next part of this is to expand. If I get 3 squared, 3 times 3 gives me 9. Plus, negative 4 squared is negative 4 times negative 4. A negative by a negative is a positive. 4 by 4 is 16. Equals 25, 25. When we add the two of these together, we get 9 plus 16 equals 25. Equals 25. That proves that this point is on the circle x squared plus y squared equals 25. It's the same when you're working with coordinate geometry of the line. If you're asked to prove that a point is on a line, or if you're asked to prove that a point is in a circle or on a circle, you just need to sub in the x and the y value, and you should get a number equals a number. Okay, so those numbers have to be equal. If those numbers were not equal, then that point would not have been on the line. So if we got, for instance, 21 here equals 25, 21 does not equal 25, so that would suggest this point is not on the line, or on the circle in this instance. So that brings us on to part 3. So now it's saying write the coordinates of 2 other points that are also on the circle S. Okay, so we've just proved that the point 3, negative 4 is on the circle, because when we subbed in the value 3 and negative 4 and we put them into the equation, we got an answer of 25, and we got 25 equals 25. So straight away that should be triggering in your head that you have a centre 0, 0, and I just sketched that here. So a centre of 0, 0. We knew that the radius was 5, so we know we can come up this way and we'll have a point 5, 0. We also know that we can come straight up this way and we'll have 0, 5, because the radius is still 5. So you're going 0 on your x-axis, 5 on your y. You can go back 5 and you'll get minus 5 and 0. And if you start at 0, 0, you can come straight down 5 units and you'll have 0, negative 5. The point that we started with was 3, negative 4. So 3, negative 4 is here. Because our centre is 0, 0, we should be able to spot the fact that this will be a mirror. So this here is going to act as a line of symmetry, you could say, or an axis of symmetry. So everything is going to be the opposite over here. So I'm still going to be out 3, but instead of coming down 4, I'm going to go up 4. And similarly, if I was at this point, I could work this way. So if I was at 3, 4, I'm still going to be on the 4 on the y-axis, but my x value is going to be negative 3. And similarly, I could come straight down this way, because if I know that this point here is negative 3, 4, I know I have another line which is straight down here at negative 3, but obviously the y value, instead of being a positive 4, it'll be 4 units lower, so it'll be negative 4. Okay, so any of those points would have worked. If you use trial and error and use points that did work, you still got full marks, and that was 5 marks for that question. That brings us on to the next part. So the next part is find the point of intersection between a different circle K and the line L. You've got a circle and you've got a line. Circle's obviously this one with a centre of 0, 0 and a radius of the square root of 13. This one here is obviously a line. Now, on the Leaving Cert, there is simultaneous equations. So simultaneous equations, if you've got two equations with two unknowns. So here we've got two equations. We've got one being the equation of a line, one being the equation of a circle. We've got two unknowns because we've x's and y's in the first equation. We also have two unknowns in the second equation because we've x's and y's. So if you've two equations with two unknowns, the only way you can solve that is by using simultaneous equations. So there's two ways they can ask this. They can ask you this by giving you a quadratic and a linear, or they can ask this in coordinate geometry with the line by giving you two linear equations. This is probably the harder of the two because it's a quadratic equation and a straight line. So in order to be able to solve a quadratic equation, what we need to do is we need to take, if you have a linear and a quadratic, you need to take the linear one and you need to rearrange it. So what we did was we took the linear equation, which was this one, and we changed it. So we wanted to get y by itself, because if we get a value for y, we can sub that in. So what we did was we took the linear equation, I just wrote it out here. I wanted to isolate the y term, so what I did was I brought the y over to the other side, and that made the y a positive because it moved across the equal sign. Anytime you move something across the equal sign, it changes sign. So it was a negative y. When I brought it over, it turned into a positive y. The equal sign stayed where it was, the 5x stayed where it was, and the negative 13 stayed where it was. And now I can say that y is equal to 5x minus 13, 5x minus 13. So that's great. What I did there underneath was just to give you an idea of what that looks like. It's going to be a straight line graph. It's going to have a positive slope of 5, so it's going to be quite steep. And it's going to intersect the y-axis minus 13. Okay, so next thing we need to do. So now that we rearranged the equation, I then went over here and I looked at how I can use that information, right? So I took the quadratic equation, that's the quadratic equation, or the circle you could say, and I subbed in a value for y. So wherever I had a y, I put in what y was equal to. It was equal to 5x minus 13. So instead of y, I put in 5x minus 13. The reason why I do that is because now I'm dealing with just just x's and numbers. So I've got x squares, I've got more x's, I've got numbers, and I've got numbers. The only unknown I have is going to be an x. So I expanded it. I went from x squared stayed where it was. Here, I needed to expand this. So 5x minus 13 to be squared is the same as 5x minus 13 multiplied by 5x minus 13. And all that is equal to 13. That's still equal to 13. The next step was to expand the brackets here in red. So the x squared stays as it was. When I expanded this, I broke it up. So I took the first term, which is 5x. I multiplied it by everything in the second bracket, which is 5x minus 13. I then took the second term, which is minus 13, and I multiplied that by everything in the second bracket, which is 5x minus 13. And I left that equal to 13. Okay. The next step from there was to expand this even further. So the x squared stays as it was. The 5x times 5x gives us plus 25x squared. The 5x times the negative 13 gave us negative 65x. The negative 13 times the positive 5x gave us a negative 65x again. And the negative 13 times the negative 13, and negative by a negative gave us a positive, and 13 by 13 gave us 169. And all of that is equal to 13. The next step was just to tidy up what I had. So I brought all my x squares together. So if I added 1x squared and 25x squared, I got 26x squared. My x's came next, so I took my negative 65x and I subtracted another 65x, and that gives me a total of negative 130x. The plus 169 stayed where it was, and I brought this 13 over, and that became a negative 13. So I just did this in two steps. All of that then will be equal to 0 because the negative 13 is after being moved, or the positive 13 is after being moved over, so there's nothing left on the right hand side. The next step from here was to tidy up the numbers even further. So negative 26x squared stayed where it was. The negative 130x stayed where it was. I tidied up the numbers there, and 169 take away 13 left me with 156, and that was equal to 0. The next step from there was to stop and look at what I had, and I could see by this that I had a quadratic shape. Okay, so I knew I had a quadratic. The numbers are quite big, so looking at this I was thinking, is there any number that divides into each of these? And I took out my calculator and I started typing in numbers to see if there's a number that's common to all of these. Okay, so a number that's common to all of these. The first one I tried was actually 26, and the reason why is because if 26 goes into 130 and 156, it'll reduce this down massively. And as it happens, when I divided each of these by 26, it divided into this one time. 26 divided into a negative 130 negative 5 times. And 26 divided into 156 6 times. So I knew I had x squared minus 5x plus 6 equals to 0. I could have factorized this, but it would have been really, really hard because I would have been using really large numbers. So it was good that I was able to take common factor out and reduce this down. When I came to this, I now had a quadratic, so I could solve this quadratic. The easy way for me to solve this, or the quick way for me to solve this, was to take the last number, which was plus 6, and to get the factors of 6. So the factors of 6 are going to be 1 times 6 or 2 times 3. I need to look and see, can I use one of these factors here, one of these sets of factors, can I use one of these to make a negative 5x? So if I looked at this one here, so looking at the 1 and 6, if I chose the 1 and 6, I could say negative 6 plus 1. Negative 6 plus 1 would have given me a negative 5, but if I times negative 6 by plus 1, I get negative 6, and that wouldn't work for this. So then I went on to my second set of factors, which was 2 and 3. So I needed to make a negative 5, so I took these two factors here, and I said minus 2 minus 3. If I use minus 2 minus 3 and add them together, I get negative 5, so that works. If I times them, minus 2 times minus 3, a minus by a minus gives me a plus, and it gives me a plus 6. In this case, I wanted a plus 6, so that worked. So what I did was I subbed in these factors here. X squared stayed as it was. Instead of writing minus 5x, I wrote minus 2x and minus 3x. Positive 6 stayed where it was, and that was all equal to 0. I now had 4 terms, okay? If I have 4 terms and I'm looking to factorize, I can always group. So I took these 4 terms and I paired them. So I put the first 2 together and I put the last 2 together. I then took out a common factor for the first 2 terms. So a common factor for the first 2 terms in this case was x. So I took out the x. Always try and take out the highest common factor, and the highest common factor was x. X came out, so x times something gave me x squared, so I knew that was going to have to be x. X times something gave me minus 2x, so I knew that had to be negative 2. The next thing I did was I looked at the second set of factors, when I was grouping my second set, you could say, which was these two, and I took out the highest common factor again. In this case, the highest common factor was going to be 3. Now, I knew I needed this and this to be the same, so I took out a minus 3. Because by taking out a minus 3 times a positive x gives me a minus 3x, so that works. And a minus 3 times a minus 2 gives me a positive 6. I now noticed that this here and this here were the same, so because they're the same, I was able to pull them together. So I took what I'm now highlighting in green, I took the x and the negative 3 and put them together, and I multiplied that by the x and the negative 2. I left them equal to 0 because that's what my equation was always equal to. And from that I knew that either this here had to be equal to 0 or this here, the pink, had to be equal to 0. If x minus 3 was equal to 0, x was going to be equal to 3. Because if I bring the negative 3 over, it turns into a positive 3. If x minus 2 was equal to 0, then x was going to be equal to 2 because I bring a negative 2 over the sign and it comes into a positive 2. I now have my x values. I had my first x value and my second x value. Remember, I'm looking for 2 coordinates, okay? So what I did was I took my x values and I subbed them back in to find my y values. So I took my equation, you can see it there, but instead of x, I put in what the x value was equal to. The first x value was equal to 3, so I put 3 in instead of x. So here's my equation. I'm writing it out, but instead of x, I'm putting in 3. That gives me 5 times 3, which is 15. 15 take away 13 leaves me with 2. So my first coordinate was 3, 2. My second coordinate, I knew the x value was going to be equal to 2, so I took the equation of the linear equation, I wrote it out, and instead of x, I put in 2. So 5 times 2 gave me 10. 10 take away 13 left me with negative 3. So my second coordinate was going to be 2, negative 3. So that was the end of that question. That question was worth 15 marks, and that's the end of question 2.